if you click on the link in Sakai, you might get to this screen, or it might just work. If I say allow, I can just tell it to go. Oh, sorry, that was my hand being on the tablet. That wasn't part of the simulation there. And it opens up to this. I can control the sizes of both charges down here. I can look at the distance between them up here, and it gives me the magnitude of the force. Notice right now I have an attractive force because both arrows point towards each other. But if I change one of the charges to a negative number, now I have a repulsive force because the arrows point away. So here we see that like charges are going to attract, opposite charges will repel. Okay. Now, let's take it back. So this was at 1, so where it started. And the question is, what happens if the value of one of the charges doubles? Right. If value of one of the charges doubles, that goes from 1 to 2. Oh, I should have looked at the force up above. So 0.9 times 10 to the fourth to 1.81 times 10 to the fourth. 0.9 times 2 is 1.81. So we see if the charge doubles, the force doubles. Now, the next question that we want to look at is what happens if we change the distance? Currently, we are at a distance of 1 meter. If I double the distance, let's see, if I grab a charge and I move there, not quite, oh, that's only 1.2, so, oh, there we go. Here I'm at 1.5, and here I'm at 2. When we were at 1 meter apart, if you might recall, the force was 1.81 times 10 to the fourth newtons, and now it is at 0.45 times 10 to the fourth. So when I doubled the distance, the force went down by a factor of 4. This is very similar to what we saw for gravitation. In fact, it is identical to what we saw with gravitation. If I double the distance between my charges, the force goes down by a factor of 4. If I could triple the distance, then the force would go down by a factor of 9. If I take the distance and I start at 1 meter and I put it at 0.5, roughly, does my force go up by a factor of 4? I was at 1.81. And if I multiply that by 4, I get 7.24. Here I'm at 7.43, but I don't exactly have the distance down to 0.5. I have it at 0.49, so it's close. It's close. So double the distance, the force goes down by a factor of 4. Half the distance, the force goes up by a factor of 4.